is Daria. I'm from Team Ukraine, and now I will perform you a problem number 13, egg white pearls. As this problem, we were asked to investigate the phenomenon of egg white pearls that are produced into the heated oil, then find dependencies on the main parameters, and we can start. Here you can see a video. I think all of you saw it, so we can go there. And let me describe this video. At the very first moment, we see the thickenings that form into the egg trays. But at the end of the video, these thickenings became egg white pearls that we will describe. But there is a question either due to hydrodynamic instability that exists in the flow, or is it due to microstructure of egg white? At this point, we can structure our report as follows. First, we will describe the mechanism of pearl formation. After that, we will make a theoretical model and some estimations. And finally, make some experimental dependencies. So, mechanism of pearl formation. Where does these thickenings form? Firstly, we decided what if we will reject oil and see what will happen on a plate, so without oil. Will we see thickenings and pearls or not? And really, with the help of following setup, we put egg on a plate without oil, as I said, and we really see thickenings. So it isn't the process that happens in the oil, and it happens in air. We need some air phase for this egg white for these thickenings to form. But really we need it. We decided to reject space for egg white situation and put like this. At the first case, we don't see any thickenings. So there may be some space for this jet to thickenings to form. Next, we describe two variants of ejection of egg white. First, we will handle syringe above the oil and eject like this. And we can eject by handing the syringe inside the oil and like this. What will we see? Here you can see the picture of effect. So we see clearly spherical pearls when we handle syringe above the oil, and we cannot see even clearly the trace of egg white when we put syringe inside the oil. So at all our experiments, we handle syringe above the oil. At this point, we can make an intermediate conclusion. The pearls are not the result of hydrodynamics and due to the microstructure of egg white. And let's move on to theoretical model and estimations. Here you can see egg. We take only egg white from it. Egg itself consists of 85% of water, 10% of proteins, and 5% of other. Proteins itself form a little microspheres, globe structure, and these globes itself form chains of these globes. At the egg white, these chains of globes mixed here and make the bonds between chains. If we will mix egg white, we will destroy these bonds between globe chains, and we expect that we will not see effect. So we stir this egg white, and really with experiment on a plate, we cannot see egg white pearls on a plate. If egg white stretched and handle above handle from the syringe, we claim that there are strongly entangled clusters of these chains, and between them there will be necks where the chains are weaker. And we see stretching of the jet. And by this photo, we can describe stretching of these jets. We can estimate forces, as you can see. It's pretty easy. This part of jet move to the bottom of the oil, and the oil will be a spherical pearl. But firstly we need to introduce the new parameter as volume tension. And it is as surface tension, but because of very complex bonds in the egg white, there will be a volume tension. From this photo we can estimate it like this. So now we write force balance, the volume tension that handle our egg white in a syringe, and the gravitational force that put it down. From this we can estimate the size of pearl. We can find the function of radius of the pearl on the bottom in oil as a function of radius of the nozzle, and get the following dependence. We need to remember it because we will use it in our experimental part. And now it is. We use following setup. In each experiment we variate only one parameter and see what it was. Firstly, we find dependence on a radius of the nozzle. We have such nozzles. We provide an experiment, conduct an experiment with every nozzle, with every time such height of an oil in vessel, and see these pictures. Then, after digitizing each picture, we obtain distributions of sizes of egg whites in oil and find the average radius of each pearl. And then put points on the plot where you can see average radius of the nozzle radius. And as I said in my theoretical part, the dependence may be like this, and it corresponds very well. Then we make dependence on the temperature, but there is a problem that we can work only very little range of temperatures, because under the 30 degrees the egg white doesn't coagulate, and above 120 degrees egg white very actively boil, and we cannot observe this effect. As you can see on photo, there will be no dependence on temperature. And there is a very interesting dependence on height. If we will rise a height from which we eject the egg white in the oil, at lower height the distribution will be very smooth, but in a very big height this distribution will have a very prominent peak. I think it's interesting. And the dependence on the speed, only in a lower speed we will see spherical pearls, and in a higher speed these pearls will be longer and thin. I think it's like a logic. And interesting photo that when we tried to use water instead of oil, we obtained such a picture where we cannot see not pearls, no traces, no thickenings, and I think this picture very interesting. So let me go to conclusion. We qualitatively explain this effect, explain the stretching of the jet, estimate the pearl radius as a function of nozzle's radius, find the dependencies on radius of the nozzle, on height, on temperature, on speed of motion. Thank you for your attention.